This should go a little bit faster because we already know the values of cosine and sine. We've already talked about them for a lot of these. But you'll notice that now instead of going from negative pi over 2 to pi over 2, I'm going from 0 to pi. And so when we think about cotangent of 0, that's cosine of 0 over sine of 0. And that's 1 over 0, which is undefined. Okay. When we think about cotan of pi over 6, that's cosine of pi over 6 over sine of pi over 6. And that's the smaller angle. And so I'm not as far up as I am to the right. So this is root 3 over 2 over 1/2. And the 1/2s cancel, so I get root 3. And you notice that's positive. And then at pi over 4, it's equal to 1. And then at pi over 3, because that's where sine and cosine are the same. And then at pi over 3, we're basically switching these values. And so that's when I end up with my root 3 over 3. And then at pi over 2, we're switching these values, which gives me 0. And then I go negative to root 3 over 3, negative 1, and negative root 3, and then this is undefined again. Okay, so these are our values for cotangent of x. And if I graph this the same way I did that one, I think this time we can focus more on the pi over 4s. So I actually think I'm going to count in terms of pi over 12. It's a good practice for the problems that would require a pi over 12 scale. And so if this is pi over 12, then this is 2 pi over 12, which is pi over 6, and 3 pi over 12 is pi over 4, and 4 pi over 12 is pi over 3, and 5 pi over 12 is 5 pi over 12, and 6 pi over 12 is pi over 2, and 7 pi over 12 is 7 pi over 12, and 8 pi over 12 is 2 pi over 3, and 9 pi over 12, if you divide by 3, we get 3 pi over 4, and then 11 pi over 12 is 11 pi over 12, and then 12 pi over 12 gives me pi, which is the same scale we used up here. It's just I'm doing the ones in between. And then we have our 13 pi over 12, and 14 pi over 12 is going to be 7 pi over 6. See, that's the same values that we had here. And then we have our, did I miss one though? I feel like I missed one. 7, 8, 9, 10 pi over 12. I missed 10 pi over 12. Nobody stopped me. So 10 pi over 12, when we divide by 2, we get 5 pi over 6, and then 11 pi over 12, and then 12 pi over 12, and then 13 pi over 12, and then 14 pi over 12 is 7 pi over 6, and then 15 pi over 12 divided by 3 is going to give me 5 pi over 4. And then we have our 4 pi over 3. Okay. So doing the same thing in the negative direction. You can listen to my son play the piano while we fill this out. He's trying to learn Frozen. Let it go. All right, and the same thing here. I'm going to go up by ones here. And so the difference here is at 0 is where we had our vertical asymptote. So that was here. And then at pi, we had our other vertical asymptote, which is here. And so we can actually fit 2 complete cycles in here. I know we had 2 complete cycles with tangent, but they were sort of cut off at the end. So we're going to be able to see both pictures here. And so it's at pi over 2, negative pi over 2 with pi over 2. That's where our zeros occur. And here, instead of starting at negative 1 going 0 and then 1, we actually start positive 1, 0, negative 1. And again, here we have, oh, jeez. What did I do here? Definitely have negative 2 pi over 3 twice. And I'm just letting you guys down today, huh? So this would be negative 3 pi over 4, negative 5 pi over 6, negative 11 pi over 12, negative pi, negative 13 pi over 12, negative 7 pi over 6, negative 5 pi over 4, and negative 4 pi over 3. Sometimes you just gotta say it out loud or else you're gonna mess it up. Okay. I knew something didn't look right there. Alright. So we have our 1, 0, negative 1 here. And the shape looks the same. Okay, we're going to start at positive infinity. We're going to come through these points sort of in a straight line and then curve down towards negative infinity. So this is what cotangent looks like. This is the most basic cotangent curve. This is y equals cotan of x. And then again, this would start, this would be 1. This one would actually be negative 1 here. We would see it coming down here. We would see it coming from above. So there's tangent and cotangent, okay? That is not what I wanted to happen. So looking at the facts that we saw about this, if we look at those two graphs, we see that both tan and cotan have a period of pi. The domain is all real numbers except for pi over 2, odd multiples of pi over 2 for tangent, all integer multiples of pi for cotangent, because that's where, in tangent, that's where cosine equals 0, and in cotangent, that's where sine equals 0. The range is all real numbers. There's vertical asymptotes where the domain doesn't exist in both functions. And then the x-intercepts are switched. So you can see that these are the same because opposite functions are on the top, right? So the x-intercepts happen where the numerator equals 0. The vertical asymptotes happen when the denominator equals 0. And then because tangent is sine over cosine, we have that origin symmetry. And then cosine over sine gives us that same origin symmetry, because when you have an odd and an even function being divided, an even divided by an odd is going to give you an odd function. So both of these are odd functions. We're going to pick up on the next video, and we're going to graph some of these functions, and we'll go through the process of doing that.